All right, it is time to talk about Git. Let's see, let me adjust my terminal actually. Can you guys see that in the back? Can you read the words? Yes. Do we have unanimous acceptance of that size text? Yay. All right. Well, I'm Matt Newsom, and this is Des Moines Web Geeks. I'd like to thank our sponsors, Goodsmiths, for hosting us. Thank you for your nice facility. Paragon IT Pros for providing us pizza and drinks. Thank you so much to them. They do not have anyone here with us tonight, but I will send your thanks back to them. Des Moines Web Geeks, many of you know, is a group for people who like to do web stuff. Maybe you're a pro, maybe you're front end, maybe you're back end, maybe you're a blogger, or maybe you're just someone who wants to learn about the web, a student maybe. We try to make events that are interesting and applicable to everybody so that everyone can plug in and learn. This is something we don't do too often anymore, and this is going to be more of a hands-on lab instead of a dojo. So I want you guys to have your laptops ready. We're going to talk about Git, and we're actually going to begin using it. And we will take the time to make sure that everybody gets their questions answered. If you're doing something and it's just really taking a lot of time to get working, I might pass you up and come back and help you afterwards. Just let me know. But don't wait till the end to ask questions. If you have a question, ask right away, because I would hate for you to get stuck on something at the beginning and totally miss what comes later on in the presentation.
Matt, let me jump in right quick. Do you want us to just talk out loud, or do you want us to use the chat feature?
Talk out loud.
Okay.
You can interrupt me, that's fine. That's what other people here are going to do. They'll probably wave their hands a little bit, but I can't see you, so you have to just interrupt me.
Sure.
And don't be afraid to butt in, because I really do go. I'll steamroll over you if you don't make yourself heard. Okay, I am not a Git expert. I've been using distributed version control as a developer for the last 5 or 6 years. The tool that I use most is Bazaar, which is very similar to Git, and yet Git has a command line that is different from everything. And so I am not a Git expert, but I am very comfortable with distributed version control, and I remember how hard it was for me to get adjusted to it when I made the switch from Subversion. And so I thought I'd try to share what little bit I know to help you guys get past that hurdle. Who here uses version control? All right, we have unanimous version control users in the audience. Good, so I don't need to explain it in depth, but I will just cover it quickly. And that is, version control is just a software tool that allows you to keep track of changes to the files. And it's often used in teams. Who here has not used version control in a team environment where you share code with others? Okay, I've got a few people who have used version control but not as a team. That's fine. So we're going to start out using Git without a team, and then we're going to incorporate using it as a team. So let's see, what is it? It tracks changes to files over time. This is really awesome for a couple things. One thing that I like to do is I like to go back and see how a file changed. So for example, you might have noticed a bug appeared on your staging server, production server, and you think to yourself, how did that get there? You know, you look at the last few revisions of your code and you realize maybe 3 weeks ago you made a change that had unintended consequences. So you can trace it back. Or maybe you found out it was someone else on your team and you can blame them. You can say, shame on you for breaking the code. It also allows you to roll back. This is actually why I started using version control. When I first did web development, I used Dreamweaver. And Dreamweaver has this nice little feature that lets you check in and check out code that actually does not work. So it's a false sense of security. And we were always overriding each other's changes on production. So I said, we got to find something new. And we started using CVS, which is an older version control system. And it allowed us to roll back. Well, Git can do that too. Version control systems, that's kind of a primary feature. You can go back. And then many version control features like CVS, Subversion, Git, Bazaar, Mercurial allow you to have multiple people sharing and working on code at the same time. Now this is a really awesome feature because 2 people can actually edit the same file at once So for example, you might be changing line number 23 and you're changing line 400. And then you save your changes. Now, if you're in Microsoft Word and somebody makes a change to opens a file and then you open it, they make a change and then you make a change, then their changes are gone. It just blows it away when you hit the save button. But in version control, it says, oh, he changed 23, so we're only going to save that change. And he changed line 400, we're only going to save that change. And it kind of combines them magically. And it does feel like magic when you use it. And then you get so used to it that one time when it doesn't work and it sends your code back to you saying that there's a conflict, you go, whoa, what do I do now? We'll talk a little bit about that. It's funny, I was preparing my presentation and I was actually having a hard time creating a test scenario where we could actually test conflicts. I'm not confident we're going to be able to reproduce it, so hopefully we can do that, because that's a really fun and scary thing to happen. So why is Git different? Now, Git is a distributed version control system, and so that means when you grab a copy of the code, you have a complete copy of the entire history of the system. So you can go back to day one. Now, again, I've been using distributed version control for so long now that this has just become common nature to me, and it's hard for me to remember what it was like before this. But in Subversion, when you make a change to your code, then it actually has to talk to the server, and it commits your changes at that moment. And that can be kind of cool. For example, we used to use hooks in Subversion where whenever you would make a change on the server, or the server would say, oh, I just got a change. They just changed line 23, and it would fire off like an email, or it might fire off automatic tests. With Git, it's a little different, because when you make a commit, nobody knows about it but you. Your local copy of the code is now the server for just you. And if somebody says, hey, Matt, can I, let's say you have this cool widget project and you download a copy of the version control and you start making changes. Well, now somebody else can copy your branch and work from it. So now you could be their server. They get a copy, and now they're their own server. Their friend can copy from them. And so everybody can have their own complete history, everything of it. They've got everything. I'll tell you, some people say, why would I want that? Subversion's nice. We all sit here in our row of cubicles. We all download our code. Whenever we commit, it all goes. And that's nice. Git is really great for distributed teams. And the internet is really one big, huge distributed team. So if you work with open source software, you've probably been affected by Git, because Git has been so tremendously useful to the open source software world that they're adopting it like crazy. So I know we've got a couple Drupal users here. Drupal is in the throes of changing over from a really mega Subversion-based system to using Git. I used to, until last week, work at a company called Canonical. We made Ubuntu. And everybody, well, about 70% of the company worked from their house. Only 30% worked in offices, and even those offices were spread all over the globe. So we all worked different hours. There was no central file server. There was no VPN. There was no nothing. We all worked on basically our own clone of the code base that we needed to. And then we would share revisions with each other by pushing. And that leads to probably the final point that I wanted to mention for Git, and that is it really works good if some developers have read-only access. In the open source world like Drupal, there's only a handful of people who can actually change the core central files of Drupal to become the zip file that you download. And that's good. You want a few trusted people to be the maintainers of core, or trunk, or origin, or head, or whatever you want to call it. And there's lots of people who contribute, but they only have read-only access. And so what they do is they fork Drupal, and they make changes to it, and then they propose their changes for review. And we'll come back to that. That's a really important feature in using Git as a team. So who should use Git? First of all, people who like pain. Who here knows what I'm talking about? Not as many people raise their hand as I thought. So
can I scream out loud? Yes.
Yeah, Kenny agrees. For me, the mental shift from regular version control to distributed version control was really difficult. And so then I learned a tool that I thought had a really good user interface. It made sense to me, and then I had to make the change to Git. And Git's user interface, even today, does not make sense to me. It's kind of like some of those really difficult theological concepts that don't make sense if you really want to try to logically consider them. You know, you just kind of have to accept them. Well, Git's user interface is kind of like a new faith. You know, you don't really understand it, you just accept it. This is how it is.
You accept it on faith.
Well, you know, G does come after F, so it's like the new thing after faith. Sorry, that was a stretch. All right, so that's enough talking. Let's do something. We're gonna make our own local Git repository. So what I'd like you to do is I'd like you to open up a terminal, and we're going to make a folder. And we're going to go into it. And this is going to become our new Git branch, our new Git repository. I always start projects with a README. From me, most of them. Okay, so now we've got a new code branch. It's really cool. It does all kinds of great stuff. But we want to share it with people eventually. And we want to be able to track our changes so that if we have a little bit of a late night coding session that goes awry, then morning we can wake up and go back. So we are going to initialize a repository with git init. And that was easy. What do we have? We have nothing now.
Man, I got a stupid question. I'm not a VM guy. I guess I use my VM in the hierarchy.
You can use any editor you want. Please use any editor. Any editor you're comfortable with.
Matt, let me jump in. Is there a screen that you're typing on in the command line that I can't see, perhaps?
You can't see it? Okay, just a second. We'll fix that. Right, I need to share my whole desktop, not just my...
We got to compare your...
Don't share that, please.
No, I made it small. It's... Can you see it now, Kenny?
Yes.
Awesome. Okay. That might make a little bit more sense to Kenny, at least. All right. Okay, so has everybody initialized a Git repository? Raise your hand if you have not. Do you have a laptop?
No.
Okay. How good are you? How good are you at whistling? We could hold a phone and you could whistle into like a modem, you know? You guys okay back there? All right. So it looks like we've got no change. We did initialize the repository, but we don't actually see anything here. So let's look at hidden files. And we've got a new folder called Git. .git, I mean. In the Unix world, dot at the beginning means hidden. And if we look inside .git, we'll see that there's stuff in there. And I don't really care what that stuff is.
Right now, we don't want to care.
And I'll just tell you that some of these files you can poke at, like there's a config file in there. So later on when you want to make Git do some more magical stuff, look at that and there's some magic stuff in there, there's some pixie dust. So if we do so what we've done is we've initialized a repository, but there's nothing in it. It's basically an empty repository. So what we need to do is we need to add our file. So we're going to do a git add, and we're going to add readme. And now we've added it, but it's not actually it hasn't been committed yet. We've not stored a revision of it. So we need to do that too. So we're going to do git commit. Now if I just hit enter, it'll pop up an editor where I can add a commit message, but I'll show you another way. Oops, that was the wrong way to do that. You can also add your commit message right on the command line. And now I have committed my file, so we actually have something. And I'll show you a command that I'll explain later on, and that's git log. And you can see here that we successfully committed something. Who was it? It was me. When did I do it? November 12th. Here's my message. Anyone baffled by this? Good. Think people are... Justin, how you doing?
I'm completely lost, but that's fine.
Okay, so tell me what you're lost on.
Well, I'm not well versed in terminal at all, so...
Okay, so some of the commands I typed didn't make sense to you.
No.
Okay, so let's just get you caught up, otherwise this presentation is not going to be any good for you. So what I did was, I started in my home directory, I made a folder.
Yeah, I'm that far.
Okay, and then I went into the folder by using cd.
Yep, I'm that far. Okay, so I guess I do understand some of this. The thing I didn't do was, so Git's good. I can check the, I can check what we've created. I did not create a README file.
Okay, so if you go to Finder or Explorer, in your home directory, you'll see a new folder called whatever you decided to call it, new project. And if you just open that folder in text editor, which, I mean, just you can use Sublime or whatever and just save a README file in there.
Oh, okay.
Thank you.
All right. Any other questions? Justin, how'd you do?
I created that README file.
Okay, now, and did you do git init?
No.
Okay, do that. Git init. Yep.
Yeah, reinitialize Git Repository.
Okay, now you want to do git add readme.
Yep. You didn't say anything, but I'm guessing it's good.
And then git commit. And then if you do a -m, you can put the message on the line. See, here's what I did.
Oh, okay. Yeah. Yep, I'm good.
Okay, so now you can tell if it worked by typing git log.
I can tell to do what?
If you type git space log, you can find out if it worked or not. You should have one revision in the history.
Yep, I'm good.
Okay. Dustin, how you doing?
I'm money.
You got it? Are you? Do you have an entry in your log? Awesome. Kenny, you doing okay?
Yeah, good.
Is the git add step necessary to what we repeat? Do I have to add it every time I hack on?
There's a shortcut to get around it, but yes.
Aha.
And that's different from other version control
Only
systems.
if the file's not already under version control.
No, even if it is. So what happens is Git says, okay, what files do you want to be part of this commit? And so you say, okay, I want this one, this one, this one, and this one, but not that one, and not that one. So even if they're already under version control, that one blew my mind. Even if they're already under version control, if you want them to be part of a commit, it's a feature, really it is. It lets you be selective about what you...
I'm sorry. That's not a feature.
Well, if the shortcut is to do git-a, or git commit -am, and the A means add.
Okay.
And that's the default behavior of some other tools.
Okay.
Yeah, that's one of those things that once you figure that out, Git starts to make a little bit more sense, a little bit.
Yeah, it sure changes your thinking away from SVN, CVS,
Mm-hmm.
Yep.
All right. So now we've got that common problem that we have as programmers, that we've got some stuff in our code folder that we do not want in our version control. And now there's, in some version control systems, you just do .ignore. In Git, it's called .gitignore. And again, it's going to be a hidden file because it begins with a period. And so, for example, Python programmers will often put that in there. Mac users will put... And then what happens is, if you've got a file in your project, it'll just pretend it's not even there as far as Git is concerned. If you do a little searching on the internet, you'll find that for whatever tool, whatever editor, whatever programming language you like to use, there's probably someone who's already got a really well thought out git ignore file that you can drop into your project, which is nice. So let's see, I'll just pretend I'm writing Python. Oops. And I'll pretend I'm using... Well, we'll just do that. Yes, exactly. So now we've got a file, but we probably want that to be version controlled, so we are going to add that file to version control. Oops. Hand was off by just a little bit. And then we'll commit it. Goodness. These people are watching me. Okay, it worked. You know how to tell? Get log. Now we have 2 revisions. Now I'm going to, while we're looking at this, I'm just going to make a little point. The revision numbers in Git are oogly. Look at that. That's a revision number. So if I want to see what changed.
That's an ID. That's a hash.
Yeah. I'm going to just see the difference between. Now, okay, no diff. So if I do. And we'll talk about diff a little bit more soon. Oh, look, it shows us a diff. But I'll just show you a nice little thing. You can just grab the first 6 characters of your commit ID and use that instead of the long thing. If you forget this, it's fine. Just use the long one. But if you want to shorten things down a little bit, you can use the first 6 characters. I've often thought to myself, this can't work every time. But it has worked for me every time so far.
So the first characters are the least significant.
I guess so.
You could also tag commits so you can reference them by something useful.
Yes, and that is a really awesome feature. And I'm going to mention this, but we're not going to actually do it. There is a really great tool for teams called Git Flow. And it's actually not really a tool. It's got a little bit of code involved, but mostly it's a way of managing your Git repository that's really great for production quality usage of Git. And it basically, it lets you have named branches. So you can have like a branch called production, a branch called staging. You can have a branch called version 1.0 and a branch called version 1.2. And that way, whenever you make a set of changes, you can publish it into your version 1.2 branch, and then you publish that to staging. Once it works on staging, you publish that to your production. You know, it's just, like I said, a little bit of code and mostly a way of thinking about your project that makes life really easy. So once you start to get comfortable with Git, look at Git Flow as a process for making your teams more effective. Okay, who is with me, or who is not with me at the moment? Who's stuck? Great, we're doing awesome. So this is how my team works. Now we use Bazaar, but it's the same in Git. What we would do is we have a trunk branch. That's where all of our code lives. And then if we got a new feature, let's say we've got bug 12 that I need to work on. So I'll create a feature branch, and I'll usually call my feature branch bug 12, but you might call it, add a new README file. You can call it whatever you want. I mean, there's rules. You'll figure that out. But you create a feature branch. And then on your feature branch, you hack on it. I tend to commit often. It's kind of like, Control S or Command S is kind of that save thing. Anytime I do something that I think is substantial, and worth remembering or being able to go back to, I'll go ahead and commit. And that's fine, because nobody else in the world will be able to see that. It'll just be for my records. So I'll hack, commit, test, and then do it all again. So it might take me 5 or 6 commits before I've got something that I'm ready to show the team. And then when I do that, I'll propose it for merging. So I'll say to the team, I'll push it to my own private space, and I'll say to the team, I want to push this into our trunk. I want to push this into our head or our origin or our master. I want you guys to have this code. And it won't actually push it in. It'll just create like a diff file, which is a file that shows the changes between my version and theirs. And then someone will review it and say, it looks mostly good, but you're going to have a race condition here. So why don't you hack on that a little bit more? And so then I'll go and hack some more, commit, test, And then I'll finally get that done, and I'll propose it for merging, and they'll say, oh, awesome, this is going live. And they'll take my code, and they'll pull it into the mainline branch, and then that's it. My branch can no longer needs to exist. This is a really good workflow. So I would suggest if you use Git on a team or any kind of version control on a team, doing something like this. And we're going to do that ourselves briefly, here in a moment, briefly, when we talk about GitHub. By the way, GitHub uses its own language for describing Git functions. So you will hear things talked about in the sense of GitHub that aren't used anywhere else in the Git world. For example, forking. So that's just life. There's going to come a point in time where you're going to want to know what happened. We already talked about git log. There's also going to come a point in time where you're wondering, what's going to happen if I commit right now? Hello.
Hey,
You came at 7 because the food was
I knew that.
Okay. We ended up eating really fast,
Okay.
and so we started early.
I'll catch up.
Okay, so I've made change to my README file, and then I went for lunch. And then I come back and I thought to myself, what did I do before I went to lunch? Did I have anything that needed to be changed? The way to find out is to type git status. And it'll say, there's one file that's modified. Or if I create a new file, it'll say that I've modified README, and I've got an untracked file called newfile.txt. So git status is just kind of status. You know, that is one command that's aptly named. Sometimes you're going to want to know what changed. In that case, I mean, it's not knowing the file name's not enough. Hey, Jake, how's it going? The file name's not enough. You actually want to see the code. So then you use Git Diff. Some of you guys are humans and are not used to reading diffs. Raise your hand if you're qualified for that, if that fits your description. Yeah? Okay, so a diff, I'm going to save this actual explanation for just a little bit because I wrote a really cool slide. I don't want to get ahead of myself. Diff basically just shows you the changes. You can see here that in readme.txt file, I added a new line that says goodbye cruel world and a new blank line after that. No magic. Git diff is really useful. It's the number 1 command I use in Git. Now that also might be predicated on my workflow. I told you guys about my workflow, how we often do merge proposals, and that's why we use diff so much, because we're always looking at changes. I will say though that the person who invented Git, his name is Linus Torvalds, and he's the guy who also invented Linux. And the way he works will explain a lot of Git's capabilities, because the way they work is everybody grabs a copy of the code and they make changes, and then when they want Linus or whoever the maintainer for their section of the code is to accept their changes, they email them a diff file. So this is my changes, and then the person who's got a clean copy of the code takes this diff file and runs a command, and it changes their copy to match the copy that you have. So instead of me zipping up the whole 100 megabytes of the project that we're working on, I just send you a diff file which has the 300 lines of code that I changed for my feature, which is much smaller, and I can email it, apply it to my code, and now my code is, both branches are the same, even though I only sent you a tiny little piece of code.
Take things out of synchrony. I mean, if I make changes to the same line that somebody else makes changes to, and they both send zip files.
Yes, and that's called a merge conflict, and whoever goes first wins.
Really?
Whoever commits first wins.
They don't want to deal with the merge conflict.
Yeah, the second person, when they try to commit, it says, whoa, you both changed line 23. You got to figure this out. What's that?
You manually got to say who.
Yep.
What gets committed.
We're gonna try to do that on purpose at the end. That'll be one of the last things we do, because it's definitely, all the stuff that I've told you so far, you get your head around. Have I blown anyone's mind yet? No, I haven't. It all makes sense. Okay, except for Justin. I think I've blown Justin's mind. It's because he's just looking at that black window. He doesn't like the terminal.
You just rubble on it. No,
It's because it's white.
yeah, it's
Oh.
white. It's white on my machine.
No wonder. The
My eyes are hurt.
the conflict is definitely one of the scariest parts of version control. It scares me even sometimes. So, and I've been doing it for years. But we'll work it out.
Do you find many conflicts that are more than just a couple lines in practical use in your workflow?
Yes. Yeah.
How hairy do they get? I'm curious. I mean, would it take you like an hour to figure it out, or is it a...
Yes.
Is that
Sometimes.
because people are both working on the same code and not committing very frequently, or
Yeah.
culture thing, or
It'd be the same with us and be just as hard.
Right.
So the tendency in the world of Git is to the tendency in the world of distributed version control is to work on feature branches. So in Subversion you don't use branches, therefore you are on trunk most of the time, and so you're really not very far from trunk very often. In the world of distributed version control, you can get far away from trunk, and so you have to either consciously make an effort to bring in changes, or consciously make an effort to manage the conflicts afterwards. So this is the common workflow. Again, I'll just go over it because it's one of those things that you won't really understand it until you do it. But maybe if I say it 5 times, it'll make sense. And so you make a feature branch. So what you do is you take trunk or head or whatever you want to call it, and you start hacking on it. Once you've got things done, you might have a big file. You might have a big diff. I hate when people do a merge proposal and they've got like a 1,000-line diff. But sometimes that's just the only way to do it. And so, if you're on merge proposal duty that day, you look through the code, you run the tests, you try to make sense of it, you get the job done. If 2 people make an 800-line diff in the same day on the same, section of code, you could have a 200-line merge conflict, and it can be a chore. If you're the guy doing the merge proposal, it's not your problem though. I mean, if you're doing code reviews, you send it back to the developer, then you say, work it out. You fight it over. But they can be really hairy. So let's talk about diff. Oop. That's what happens when you scroll there. All right, so we saw diff. Okay, let's say we want to... I've got to go to a non-trivial branch. Sorry about that. All right, so we got a little bit more history this time. So I'm going to compare this version. Oh, I can't go to the non-trivial version because you guys don't have that. Sorry. Well, we'll show it. It'll just be a little bit more contrived. That's all. So if I want to see the diff since the very beginning, I can just type 1 revision number. And remember, you only have to type the first 6 characters of the revision number. Well, I chose, since I only have 2 revisions, I chose the first revision, and so yeah. But normally you don't go back to the beginning of history. That's not very useful. And I will say that it's more common for me to do this version where I have 2 revision numbers. I think that's more revision. I guess I do them both pretty close to equally. But this is definitely one that I use often. In this case, I use 2 revision numbers, and that shows me the difference between 2 revisions. The first number shows me the difference between now and the revision that I specify. But sometimes what you did now, you already know. It's like what happened a week ago. I want to know what happened on Tuesday. And so you go and you say, okay, the first revision on Tuesday and the last revision on Tuesday, and you compare those 2 like that.
Other shortcuts to define revision numbers, just -1 at that.
don't remember. I don't think so, but I'm not sure. That'd be nice.
I think it's minus 1, minus 2 when we get that. Yeah, that would be very nice. Yeah, and that definitely sounds like a shell.
All right, so here's the little diff trivia I mentioned before. I know that many of you guys don't use patches. They can be very handy though. So for example, sometimes I'm working on something that's a little bit too big and it's not ready, and maybe I want to grab one feature that I did. So for example, let's say I'm working on a big project, and one of the features that I worked on involved adding cache headers to a web app. So that part's done, but the rest of my code isn't. Well, what I can do is I can get a diff that has just that revision. I can do diff, revision A, revision B, and dump out that code change to a file, and I can email that, or I can set it aside. I can go to a new folder and do a clean checkout. Oops. From the trunk branch, I can apply that patch, that diff, and commit it separately from my code. That's a really good way to get a merge conflict, by the way. But that's a nice little trivia. And so I do use this often. I used to have a server. The company I worked at, we didn't get root access to servers ever. We didn't even get shell access to servers if we were web developers. Only sysadmins had that. And so what I would have to do is I'd have to take a bit of code and test it on a server. And like I was working on a branch that was 400 megs, and I didn't want to push it out there. I wanted to see my change now. So I would just do a diff, upload the patch file, apply the patch to the clean checkout, and test it. Again, it's kind of a power user feature, but that's just a little trivia. Git Diff spits out good old-fashioned diffs that you can email around. All right, let's get to something a little bit more practical. For this, we've got to count off. So I'm going to give you guys each an issue number, okay? So you're 1, Justin, you're 2, 3, no laptop. 4, 5, 6, 7, 8, 9, 10. Okay? And I'll be number 11. So everybody remember your number? Kenny, you're number 12.
Got it.
Now,
Sorry, sometimes it takes me a minute or two to unmute my microphone.
no problem. All right, so what we're going to do is we're going to go to GitHub now, and we're going to learn to use GitHub. And when I started my presentation, I thought, I'm not going to use GitHub, I'm not going to use GitHub. The reason why is because GitHub uses a little bit different semantics than the rest of the Git world. But then I started being pragmatic, and I thought, most of the people that are going to use Git are going to use it because of GitHub, so we might as well just use GitHub. So if you go to GitHub,
Does anybody else in the room use Git currently, or going to be using Git? Or
We're evaluating.
Is anybody looking at specific repositories like GitHub, or we would host it ourselves?
I have instructions for setting up your own Git server. That's really nice. So if you guys are interested in this, contact me. I use a tool called GitLab, which basically gives you your own private GitHub. It's real slick. It's great for if you have an office and you got like a bunch of people that are going to be on the same LAN, because it's super fast. It has pull requests, which is also called merge proposals in some places. It has its issue tracker, and it has a wiki. It has a nice little version graph so you can review the version history. It's cool. GitLab. And it gives you a Git server built in, and you manage it. Users log in, they upload their SSH key, they have access to the code. It's nice. And I've got the installation pretty well perfected on Ubuntu server. So if you need help with that, you can let me know, and I'll share my instructions with you.
We use GitHub here.
Yeah.
For the $25 a month for the private repo, you actually have 10 repos with that, which you can. Yeah, it's nice, and for the cost, you don't have to deal with management, and so many of your third-party tools interact with GitHub. It kind of makes it a no-brainer, although hosting your own is definitely an option, and that one in particular is pretty nice. But that's why we went with GitHub. We don't have to manage it, we don't have to have a server for it, and third-party tool integration is really nice. All the webhooks and everything, so many people interact with GitHub, it's ridiculous. It's going to stay here.
GitHub is definitely an awesome tool, and I would highly recommend it, especially if you want to start out practicing with Git. You can start out by, just using some open source projects on GitHub.
So is GitHub making the GUI instead of command line? Or am I totally...
They do have a GUI tool that you can download for Windows and Mac, and it's nice. But it's also, it ties you into GitHub. So there's a couple other tools out there. Are you on Mac or Windows? Okay. Like Tortoise Git is a tool that lets you use that. I'm pretty sure that Visual Studio supports Git. Eclipse supports Git. JetBrains, yeah, all the JetBrains tools support Git. And that was the other tool I was going to mention. Bitbucket really has about all the same features as GitHub does. The difference between GitHub and Bitbucket is the pricing. GitHub prices per repository. Bitbucket prices per user. And so if you have like a lot of repositories, which is my case, then Bitbucket might be a better price. If instead you have more users and less repositories, then GitHub might be a better deal. But of course, too, if you want APIs and things like that, you can't really match GitHub. They're the best. All right, how's the battery doing? Okay, we got 45 minutes left in the presentation. So if you go to github.com/DSMWebGeeks, that is the DSM WebGeeks repository. Oops. No, Kenny, I'm not playing Legend of Zelda. And then click on that GitLab link. And then I'll go ahead and click this Git read-only thing here and copy that URL. It's not like a web URL, it's similar but different. Copy that and go back to your terminal and go to a new folder. I do that by going cd ... Actually, we're going to make a new folder when we check out. So cd ... to get back to where you were. And now we're going to type git clone, and then we're going to paste in that URL. If you're in Windows, you paste by simply right-clicking. Let me make sure I'm still following the presentation. All right, so we find the URL, we grab a copy of the code, you hit enter, and it should check out the branch. And now you see here that we've got a new folder called GitLab. So if you cd GitLab, you've got, whoa, it looks just like our old branch. But if you look at the Git log, we have a history. Everyone doing okay with that? If you want to make changes to a public repository, so for example, if you do just what we did, like a lot of times you'll see this really cool project and you're like, I want to try this out, and so you do what we just did and you're done. You've got the code and that's all you care about. So this slide is not for you in that case. But let's say that there's an open source project that you want to contribute to, then you would want to create a fork. And a fork is a GitHub term that basically means you take a copy of the code and you put it into your own GitHub account so that you can hack on it. And you can push back to it and pull from it and push back to it and pull from it. You can share with other people can see your fork and fork it. That's not a problem. But for our purposes, really the reason why you would fork is because you want to push your code back to GitHub and then propose to have it merged into the open source projects or the public repositories branch. And by the way, if you have a private repository on GitHub, then this is still valid. Everything that I've talked about is still valid. So you remember that workflow where I said, you create a feature branch, you hack, then you propose it for merging? So that's when you would want to use a fork. All right, if you take your number, I created a bunch of issues. So if we go to GitHub, you'll see here we've got issues 1 through 25. So remember your number, and that's your issue, and your goal is to make a change to the line that is your number. So mine was line number 11, because I was issue number 11. So if you edit the README file, go down to the one that says, has a beginning 11 at the beginning, or no, to your number at the beginning, and just change it. Now I'm going to make a mistake. Tell me what I'm doing wrong. I didn't do an add. Yeah. I better make sure that... Okay.
So there was leaving it at default behavior.
No, not the default, but you can do it one step with this.
Alias
Look in the docs. There's really awesome docs. There's really... You would not want for more docs. As a matter of fact, you might want for less docs. But if there's something you wish, oh, I wish I could do that, check it out. Oh, and let me tell you how to do that. The first thing you can do is you can just type Git with nothing else, and it'll say, here's the things that you probably want to do, and it gives you a list. And then if you type Git, the command you want to type, and then -H, then it takes you to help for just that command. All right, so I'm going to add my file. Now, check this out. Before you commit, I want to show you a nifty feature that works with GitHub and many other systems, and that is if you mention your revision, your issue number in your commit message, it links it. So here's what I'm going to do. Okay, I just put #11, and now it'll be a link when I commit it. And you'll have to trust me because I don't know if you guys can do that, but here I'll show you how it works. No. No, but I did it earlier. So you see how this one has the underline number 26? I just made the commit message, and when I go to the issue, it shows me that this was addressed in a line of code. I can go check that change out, and wow, there is the diff. It even makes it nice and colorful. And then issues that have been mentioned like this will stand out in the issue tracker, and then I can come by and say, yep, that looks good, I can close it. Or whatever. Yeah. Yeah. And I've noticed other tracking systems do this too. So for example, if you have Redmine or Track are two other tools that do like GitHub if you want your own private version tracker, they both support that. It's so common that I'd be surprised if a system didn't do that if you use a different system. Okay, so where are we in our presentation? Okay, so we've grabbed who here has a GitHub account? Okay, so go ahead and fork it. Fork the repo. If you don't have one, just pay attention. Just watch.
So what's the difference between forking it and just grabbing it, cloning it?
Okay, so forking it is when you want to push changes back. So if you just copy it, you're anonymous user, and that's it. And that's fine. Like if you just want to grab the latest version of whatever, try it out, just clone it. If you fork it, what happens?
You go both ways essentially. You can take and give or contribute, right?
What it does is it takes a copy of that repo and puts it in your own GitHub account. And then what you would do is you would clone your copy, not the original version. And then you can push back to your copy. And eventually you can do a pull request and have the original site maintainer bring yours in. And I did not know that I cannot fork it twice. So hang on just a minute while I unfork this.
You only have a one-time fork. I guess it's 2 times.
Whoa. Well, my code has been forked a lot.
Is it forked up?
Yeah. Oh, okay, that's interesting. I'm learning too. I don't see a way to delete my fork.
The files.
No, I've got to delete the reference to it on GitHub. Oh, maybe admin.
Go to admin. Yeah.
Got it.
Are you absolutely sure? Unexpected bad things will happen.
I'm so absolutely sure.
I'm not actually that sure. We're going to find out soon. Okay, that's fine.
You should have a pull request now.
Awesome, thank you.
Matt, you should point out it shouldn't matter if you're sure, because all of us have forked it, and so we can always push it back to you.
Cool. Okay, so somebody has kindly made a pull request. Oh, let's go back to the presentation first. Let's see. Okay, if you want to propose changes to a GitHub project, you use the fork button. You can link changes to a GitHub issue number using the commit trick. Now you push your change to your own fork. So I'll do a quick fork so you can see it. So I click fork, and I fork it to my own branch. This takes a moment.
So that's okay because part of that, when you just cloned it, you could have changed it anyway, right?
Yep.
So,
And
yeah, does this combine with what you just cloned then, or?
well, it basically in this case, if I clone the main branch and then I fork it, it's two copies of exactly the same thing. It's just a reference. So I can push my, and they share a common lineage. So I can push my clone from the original clone to my private fork or my personal fork, no problem, none at all.
So the difference is where it resides, right?
Yeah, it's just a reference.
The difference is that there's a relationship.
Fork resides up in the.
Yeah, the relationship.
On your account.
I,
Way to think of like when you clone versus forking the Git repository is if you own the code base, you're going to clone it. It's something that you're working in as your team. Generally in a team environment, that's what you do. If you're going to go contribute to an open source project, generally you're going to fork that project, make your own changes, make your commits, do whatever you want to do, and then do a pull request for those changes into the original repo.
yep,
That's generally my workflow with deciding to cloning and forking.
yep. So for
They would
example,
look at your fork and see if they want to include your stuff.
Exactly, it's totally optional for them to pull in those changes. Now, you still can, and I hope you talk about pull requests in a team environment as well. I personally would highly recommend that you function in a pull request scenario. So talking about your feature
Yep.
branches. Are you going to talk about that?
yeah, we're going to do that in just a moment. And just to illustrate that, this is a little bit of code that I used one time, and it had a bug in it. And so I thought, oh, I'll propose it back to the project. So I forked it. I made a change to the code. I proposed it. I did a pull request. Actually, what I did was I sent them a diff because I didn't know how to do pull requests at the time. Or maybe pull requests didn't happen then. And they ended up not caring. And so now here's my copy of their code with that one problem fixed on GitHub for anyone else to look at. That's open source, so. Well, it was for an Amazon product, and Amazon didn't have a feature, so somebody made an open source project to provide that feature, and then Amazon made the feature, and so nobody cared about the open source project. Yeah. All right, so someone made a pull. Okay, let's go back to the presentation. I got to stay on task. Okay. So you push to your public fork. You go to the public repository and click pull request. You discuss your changes with the dev, and then the dev will do that. So I hear, oops, project am I? So here we have pull requests. So many choices. All right. It tells me a nice green sign. This pull request can be automatically merged. That's great. So I'm going to look and see what actually changed here. We're going to review his code. No, he added a new line to the beginning. Let's go look at Jim's code pull request and see what his looks like, just for fun. So these are the little short revision numbers. You see them all the time in GitHub. You just click them and they always show you a diff. It's nice. Okay, it's Jim, right? John, sorry. It's Jay. It's Jay Rearick. That's it's John. Okay, so he changed his line 9. Pretty straightforward. Oh.
Can I ask a stupid question?
And look at that. He even referenced issue number 9 in his commit message. And we can see here, this is issue number 9. And it says here, you see this line, he changed the code, and it shows the diff. So I'm in the issue tracker now. I'm up here. So if I go to number 9, you see his mention of it. Go ahead, ask your question.
And those are coming off of pushes back up on the floor?
Yeah, what you do is, so okay, let me try it.
Okay, so there's the fork scenario and the non-fork scenario. Okay, and at the moment I'm living in the non-fork scenario. How do I push back to?
You don't. You send me a diff. You send me a diff.
Yeah.
Or you go back to GitHub, you create a fork, and you push to your fork.
Very good. Very good.
Okay, so I'm going to go back.
Can I clarify your question? Are you saying you're leaving your own company's repository or some open source project?
Well, no, I'm sitting right here, right now.
Okay.
I didn't fork. I pulled it. I made a change. The only way I would be able to push that back is to have done it off of the fork. Yep. Okay, very good. Well, now you'll never know how I fixed it.
You could email me your diff.
If you forked it, pushing it does push to your root. And you can continue on. You may deviate from the original code base.
If you're using GitHub for pull requests, then you have to go to GitHub to do pull requests. If your team uses a different process, then you do not have to use GitHub.
So there's no command line to do that. That's a GitHub thing?
Yeah, all you're doing is pushing and pulling. That's it. That's all GitHub's doing here.
So it's like a process where you have like a build master or something that everything really just
That's generally how we work. So we have 5 developers. We're all working on different feature branches, and everybody's working on different stuff. And no one person knows what everybody's working on. So if you want any code, you can load it into master. So we have a development branch and master branch. Anybody can push it into development. That's not an issue. To get it into master, you have to submit a pull request, and then we'll go through it and pull it in. In a perfect world, we do code reviews and stuff like that, so we actually look at the code first. There's a certain element of it that's green, it goes. You know, but we do have testing prior to that.
All right, so what I did was I made a change to the README file. I did my git add. I did my commit. You notice in my commit message I referenced issue number 11. Okay, then I did a push, and I pushed right back to my branch that I got from my fork page. So this is my fork. I did not choose the read-only this time. I left it on what it was, and I copied that, and I copied that when I cloned it, and now I'm going to use that same reference when I push it. And it went up line, or went up. I uploaded it. That's what happened there. And now you'll see here when I refresh, instead of saying 5 hours ago, it'll say that it changed 2 minutes ago. There we go. Okay, now I'm going to do a pull request. So I click on pull request. Now this is going to be something interesting. If I would have made 10 commits, let's say it was a big feature, when I do a pull request and it's accepted, it's going to only be 1 commit message on the main branch. So it's going to be, Matt made all these changes. So it's pretty important when you leave a comment here that you really do a good job of summarizing all the changes that you've made. Yep, and that's why I have no qualms against just going ahead and committing often. So every time I'm like, oh, it works, okay, I'm going to commit, you know. So,
you want in your commit messages. Yeah.
and that's a convention, you know. And my team also had a convention that you didn't commit if it didn't work, you know. So, you know, if you're like, okay, you're hacking on something, you're hacking on it, it's not working, the tests don't pass, you hack on it, tests don't pass, the tests pass, okay, it's not done, but it does work, so commit.
So your pull request is for your whole repository and everything that changed since your last one?
It's everything that changed since, okay, let me, you check me, make sure I'm right. It's everything that's changed since you pulled last.
Right, in your branch.
Yes.
Not for your, you said whole repository, that's enough, it would be
Okay.
whatever branch you're working with, not if you're just working in
So
math.
this is on Git.
We have to be careful about using the word branch here, because that might not mean what they think it means. So let me explain it with different words and tell me if I'm wrong, okay? So let's say that you did a clone, you made changes, someone else is making changes too, okay? But you make some changes, you do a pull request, it's basically going to be just a diff of the changes that you made. Now, if you did a clone, you made some changes, they made some changes, and you're like, my changes need their changes, so you pull their changes into. That's fine, you can do that. And then when you do a push, it'll only be the changes that you actually made, not the changes that were already in there that you pulled in later. Sound right?
I can't really speak, we don't pull from peers. If you're pulling from somebody else's code, we're using GitHub as the central repo. So
So
generally,
to share, you have to go up and over.
yeah, so generally if you're working with another developer on the same code, it's in a feature branch, or sometimes we'll have two feature branches going that happen to touch the same code and need each other.
Yeah.
And in that case, one will get pushed into
Yeah.
up to GitHub and then merged into the
That's what I do too.
it's a lot easier to manage that way.
I'll say that the world of pain comes when you've been working on something so long that you haven't pushed for a week or two.
It's not the pushing part, it's really the pulling.
The pulling, yeah.
It's getting updates, so as long as everybody is
Or you've got
being courteous and pushing
refactor,
their changes,
you know, you've got a merge
the
coming in yours.
And you're
You've seen it, you've done it.
But to commit for that will help significantly if you're committing on a regular basis. If you start shuffling methods around in the file and other somebody else is working on it, you're going to go flat.
Yeah, refactoring should definitely be planned. Okay, so let's go back to the pull request. So here I am addressing issue number 11. And now I'm going to send my pull request. And remember, these diffs are so awesome. The diffs are great. Use the diffs. Okay, so are we ready for the merge proposal? I just reviewed the code. Of course, Matt writes solid code. So I hit the merge pull request. Here's the commit message that will be seen by everybody later on. Confirm message. And now it is part of code. So now you guys who have already cloned can do a pull. I'll do that. I'll show you how it works. Oops.
So they're gonna pull it, they've got changes that are committed.
Then you're not gonna get it.
Oh yeah, you're right. You're right. Okay. So what you can do, I'm working off the main one. If I do a git pull, then, oh yes, we got a conflict.
That's not the typical
When I'm paid to be a tester?
By the hour.
Oh, yeah.
Okay, so we
I
can
think
fix
that's
the
the first time
conflict.
I've ever heard someone say sweet to a conflict.
Yeah. Okay, so let's see what a conflict looks like. Okay, so we'll get status. If you ever forget like what happened, then you can do git status, and this This can be a little intimidating, but it says your branch and origin master have diverged and have 1 and 2 different commits each respectively. You know, so now it says both modified. So I'm going to edit the README file. And the, oh, look, there's the conflict.
My battery says there's 10 minutes left of the presentation.
So what I have to do is I have to figure out which one of these is right. And it is usually not this easy. And then I delete this line. And I delete anything that I don't want to be part of the final revision. Okay? Then I commit. Oops. Okay, so now my history has all this cool stuff in it. And basically, if I push now, then I totally obliterate the change I made earlier because it was only 1-line diff. But it's fixed. As soon as I put, the merge conflict is fixed. All I had to do is change it and commit it, and it's done. Did I do that too fast? Did you guys get it?
Matt, which remote are you pointing at right now?
This one is not my fork.
It's not your fork, it's the organization.
Yes, the original clone.
Okay.
For those of you that use Tortoise SVN and have a nice GUI for managing your workspaces, you have to tie into whatever tool you use. I personally use Meld. There's a dozen of them.
Which one do you use?
Meld, M-E-L-D.
Meld, M-E, yeah, meld.
Side by side.
Exactly.
Yeah, it's nice.
Your two, the right and left of the center is the join.
And if you use Eclipse or JetBrains or those, they also have it built into. All right.
Does GitHub show graphically when there are existing merge conflicts?
Yes, what'll happen is that little screen that we just saw, here, let's see.
Can you roll back a commit?
Well, this will be different. So if there's a merge conflict, then instead of a green bar, it'll be red, and it'll give you the ability to see the diff so that you can find out what it's at. And you'll have to, I think you'll have to fix it on your local copy, though.
It'll give you instructions as well as to what commands to execute if you're not familiar with it. Sometimes you get a lot of can't always click on the green button and forget. But it's basically what you just went through, the merge conflicts.
All right, and that's my last slide. Now, I thought of something that we should probably talk about. Oh, okay. So one of the things that the teams will often want to use is branches. And branches in Git are the most they're hard to explain. That's the best way to say it. They're hard to explain. And so I'm going to tell you a way to use branches that I feel is kind of natural and easy. And I already did it, but you guys probably didn't notice it. And that is if I'm going to work on a fork or a copy, then instead of being in my trunk branch, you can just go do a clone, and then you add a second little parameter after the end. You add the folder name that you want your clone to go into. So I called it Matt's fork, but I'll call it Matt's fork too. And now I've got basically a second copy of the code, and this is a pristine copy of the main branch, or in this case my fork, and then I can make a change to that and I can push it back in. So basically, like let's say that you're working on a project that's going to take you about a week to do. You get 3 days in, you've written 800 lines of code, and somebody says, we just found a showstopper on production, you fix it. And you're like, my code's in a mess, I can't push this yet, right? So what you do is you switch to a new folder, you can do a clean clone, you fix that one line fix that broke production, and you push it. Okay, that's a really easy way to get branches in Git. There is another way to do it. You can actually use the branch command, and I love Git branches. They really are good. They're just hard to explain, which is why I'm not doing it today.
What you're explaining there is going to get a whole new copy of every file, right?
Yes.
If you have a large project, you probably don't want to do it that way, or is that
and that's why I like Git branches, because Git branches let you get around it. It's just that the commands to do it on terminal, it's like 5 commands, to do stuff, and I thought of Justin. Okay, so now we've finished the presentation. We have 26 minutes left on my battery. What would you guys like to ask or discuss?
Branches.
What else?
I don't mind talking on that one, because I think your description is very accurate in regards to cloning. Git branch is a git checkout type B in your name of what you want it to be, and then whatever branch you need to come from.
Here, I can do it in the terminal if you want to talk through it.
Sure, git checkout -B, space -B, feature, whatever, feature branch name, and then that's automatically going to go for master, but normally we also put in master as well. The same thing as cloning, it's just keeping it all within one folder. It's managing it via the commits that you do. So if you say, if you're off in your development world doing whatever it is that you want to do, and so it says, hey, you got to come fix this bug that's in production right now. All right, cool. I'm going to do a git checkout -B, hotfix branch off of master. So it's going to take what's in master right now, and that's what you're working with. You make your change, you commit, you push to a pull request that you went through there, and then it gets merged into master. So you don't have to go through the whole
So how do you go back to the other branch then?
Then it's a git checkout in your branch.
Oh, okay, right.
You don't have to do the
So
dash
that
B
means
then.
It takes the changes you may have made, reverts them basically to whatever branch you're coming from?
Yeah, because it's all based on
things.
your
Right, okay.
Yep.
And then it goes back up the tree with your, okay, all right.
So it actually changes files on your files.
It is changing the files on your files.
Right, but it
It
doesn't
still
lose
has
what you
everything
already
else.
have, right?
Exactly.
Yeah, it stores what you have as that branch. If I understand it correctly, then you make your changes, you push them back, and then you get branch back to what you had before.
Yep.
And then changes
Doesn't
those
say
back.
what's
Yeah,
not
when you
staged
have
yet.
merge conflicts then.
It's not staged yet. No, I guess I would clarify and say that I would, if I'm in a feature branch or whatever I'm working in, I would first commit to that. Whether I push it or not is irrelevant. It's committed to my machine.
Right.
And then I would go and branch off master and make my hotfix.
So if you don't commit and then you branch,
You're gonna get-
you're
Oh, it's gonna be.
Yeah, you're going to get errors before you even get to the new branch thing.
Oh, it'll
I'll
catch you.
tell you there's a.
Yeah, it won't.
How do you take your hotfix and then add it to the code that you committed later?
Sure, so that's the next part.
Yeah,
I was
right,
gonna say.
right.
So you've got, talking with my hands here.
That's
So
okay.
you've pushed your stuff you were working off to the side.
Right.
You made your fix, you've pushed it out to GitHub, it's in your master branch.
So I've got
You get back in
master
your code that you were
of
working on.
GitLab,
That one
right?
you would do a
Of your
merge
copy of
manual
GitLab, yep.
version,
That I
master
forked.
branch.
Mhm.
Back,
Yeah, I just branched it.
You do a pull, right?
So I created a branch.
Of
Here's
master
how.
and merging
Just to get up to speed.
Create branch. And I just did that. So here it
So
is
yeah,
up here.
branching, it can.
And it's the one that I'm currently in.
Does
Does that create those, copy those files to my local?
No.
Where are those, do these files actually exist anywhere?
No, the only thing that exists is a diff, the difference between what should be and what is.
Oh, very nice. Okay. Okay. Where does that exist?
In the same, in your working folder.
Ah, okay, cool. Very cool.
But I like keeping them my own stuff. How bad does that get after a while?
It only stores a diff. It's not not like a really bad thing.
The list of branches are resting on clean.
Oh, I delete them when I'm done with them, because everything that's important is in the history, is in the log. So I'm just going to warn you guys that Git branching in theory is really cool. In practice, it's going to take you a couple times for it to actually work. So do it sometime when you have a little patience.
What you trip over the first time that you didn't realize.
The working copies don't change the way you expect. That's my issue. That's the thing I've bumped into. Whereas when you do a git checkout, you make your change, and then you commit, and then you do a git checkout to get back to master, and things aren't quite what I expected. So that was my problem. It just didn't all change. Like sometimes I would have files in my master that I didn't expect to be there because I put them in my branch, and so again, this is why it's not in the presentation, because while I can do it, I can't explain it.
Yeah, no, and that's valid. We went through the same issue most of us going through SQL and whatnot.
Right,
You know, when you get- There's an article, I'll tweet it out, I'll tweet out a URL that really helped us understand how to manage branching, because you have your production code, you have your development code that's often beta and testing and whatnot. You have all your developers doing all these branches, and when do you bring those together and put those in place? And we don't follow it to a T anymore, but it was a good start for us, and it was very specific with, here's the command to execute this, not just, this is what you should do. So it's pretty good. I'll tweet that.
And so speaking of things, if you guys want to use it on a team, I really strongly suggest getting used to Git and just kind of figuring out the basics, doing what we did. Do that about a dozen times or 20 times. And then if you're using it on a team, go check out Gitflow, Gitflow. And you do not have to do, it the way that he described. You don't have to use his tools, but the theory is really awesome. Okay, it's just a really good way to take best practice production, quality, code management, and apply it to Git. And so there's a video, there's some better documentation than this.
Is that shell only? What's the interface for that?
It's more of a philosophy. It's not really code.
That actually looks, that graph looks very familiar to what I was talking about.
Was it Gitflow?
It's what we have to look at.
Is it the nv.com?
Yeah.
That's actually listed as, if you scroll up right there, as the read more at, right under the code tab. Scroll back up.
Oh, there.
Text, yes, that's it.
Yes, this is the article. Right?
Yep, okay.
Yeah.
Really, really awesome tool. So, and I strongly suggest it. Kenny, how you doing there? You got any questions?
I'm good, thanks. I'm good, thanks.
Okay, cool. I think we're about to the end of the presentation. I'm going to be around for a little bit, so if you want to know something, let me know. I've recorded it. I don't know if that recording is going to be useful or if it's going to be a lot of everyone sitting there quietly while they type, which is not very interesting to watch. But I'll keep it, and I guess I'll end it now, actually. That's not it.
Bye, Kenny.
Bye, guys. Thanks again. Bye, guys. Thanks again.